Hey folks, you're listening to the Java Easily podcast, episode number 2. Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer. Hi there, welcome back to the Java Easily podcast. Thanks for returning, it's good to have you here. Now, before we get started, if you're completely new to Java and haven't grabbed your Java Beginner Starter Kit, go over to our website at javaeasily.com and grab it there. It's a super helpful guide to get you up and running with Java. It's completely free and it'll help you get set up with Java coding today. And on this episode, we're going to dive into a question that I had. Well, not so much a question, it's kind of like a pain point, if you like, which I discovered with one of the new Facebook group members. So if you haven't joined already, we've got the Java Easily Facebook group, and that's designed to be a nice, friendly place for beginner and intermediate Java developers to get help with Java technology. So ask questions, get answers, and have useful tips and tricks posted. And we're hoping to build that up over the coming months to make it a really, really nice, friendly community where you can get help with all your Java technology issues. So yeah, if you haven't joined already, just send a join request, and then we can let you into the group, and you can post questions there as well and interact with us. But yeah, as part of that, as part of the group, we ask just a couple of questions to kind of get a feel for where you are with Java and what problems you might have. And so one of the answers to those questions we got recently gave the answer that the person was struggling with unit testing. And that started me thinking really about issues people can have when they first start out unit testing, or maybe when they haven't got as much experience with unit testing as other more experienced developers have. So I was thinking, looking back when I first started out with unit testing, what kind of issues did I have? And what was the main obstacle and struggle I had at the time? And so here's my thoughts on that. So basically, unit testing in general, if it's done correctly, and by if it's done correctly, what I mean is if the environment within which you write your unit tests is the correct kind of environment to write them, and we'll come to that in a second. But yeah, if that environment is set up correctly, then unit tests are actually quite easy to write. Because effectively you only have 3 areas in a unit test which you need to focus on. Unit tests in general are broken down into 3 kind of parts, if you like, within a test method. So you've got an arrange section, which basically is the place where you can arrange the objects or the test data even that are going to collaborate together with the so-called system under test. So that's the actual object that you're testing. So just to unpack that a bit, you've got an object that you're testing, and so in your test case, you create an instance of that class. So that's the object itself. That's the one that you're going to invoke the method that you're testing against. And that object will have, in all probability, other objects which are kind of injected into it or somehow set on that object, which it will interact with to be able to get its job done. So in object-oriented systems, you very seldom have just a single object which doesn't have connections to other objects. It's more usual to have that object have its so-called dependencies injected in, which are other objects that it depends on, that it needs to use, hence the word dependency, in order to be able to get its work done. So in the arrange section, that part of the unit test method is basically setting up those objects to interact in a way that's suitable for your test. We won't go into here actually what that means because it can be quite in-depth, but just know that in the arrange section, we're really setting up the objects that are going to be interacting with the object that you're actually testing. They're called that object so-called collaborators, and that's what you do in the arrange section. Now, after the arrange section, you have the act section, and in the act section, you're literally doing the action. So you're doing the action of the thing that you're testing. So for example, if you're testing a method, make booking on some kind of booking service object, for example, imagine you're working at some kind of travel website thing like booking.com. Maybe there's a booking service, and that has a method make booking. And that's presumably called based on a web request that manages to filter down to that specific service, and you want to basically test the logic of that. So it will be that method that's the thing that you're testing. So that's the act part. Now the thing about the act part is that should only ever be one method. It shouldn't be like multiple methods. It should just be one thing and one thing only. And the reason for that is that if you were to have multiple things, multiple actions which are happening there as part of the act section, then when that test breaks, it wouldn't be clear which action caused the breakage. And also as well, it confused the arrange section as well, because then you'd be arranging objects to be set up to kind of fulfill the scenarios of those 2 method calls. So it gets very complex very quickly. So key point here is the act section is just one method invocation, and that's the method you're testing. So yes, we've got the arrange section where we're setting up the objects, we're setting the stage if you like for the actual test itself. We've got the act section, which is where we invoke the method that we're testing on the class under test. That'd be that booking service object which we just mentioned. And then the third section we have is the assert section. So in the assert section, that's where you're going to have all of your assertions. An assertion being a programmatic way of stating what you believe to be true about a particular object or a particular data value. In other words, contents of a variable. And you'll have seen these before in unit tests where you've got assert equals to assert if two things are equal to objects, for example, object instances, or asserting that things are not null. Or you can use hamquest as well, where you can use JUnit's assert that method and then pass in a so-called hamquest matcher to make these assertions more readable. So yeah, there's different ways of doing it, but ultimately in the assert section, you're effectively just kind of checking the state of the union, so the state of the world as it were, after you've invoked that test method. And if you look at things from this point of view, it makes your test methods very clear, very simple and very straightforward. Because yeah, once again, an arrange section, you're arranging the objects in accordance with how you want them to act for this particular test. The act section, you're just invoking one method, which is the method being tested. And then the assert section, you're basically checking the state of the world after the method that you're testing has been invoked to check that the things you expect about the state of the world, in other words, the values of the variables, the states of the object, all that kind of stuff, to check that that is what you expect. And the idea is that, of course, that if it isn't what you expect, then the assertions won't pass, and then the test will fail. And then when you read the test failure, it will pinpoint you to the exact assertion that was false, which didn't hold, and at that point then you can investigate why that was. And that can be made even better sometimes by giving an actual message for that assertion as well, if it needs a bit of explanation. Because then that'll come up in the failed unit test, which is in the IDE. You'll see a more descriptive message for why the assertion failed. So that's basically how a good unit test should look. Now there's different ways of doing it. There's arrange act assert, otherwise known as this AAA version we've just spoke about. And there's also given when then as well, which is kind of the same thing. So it's given this set of preconditions. In other words, these things that must be true about the world before we start the test. They're kind of like assertions, if you like, before you invoke the test method. Given those, when, and then you have the test method that you're invoking. Again, that's just a single method invocation, don't forget. Even if it's given when then, it's still just a single method invocation. And then you have the then section, which is where now you're actually putting in these post conditions. In other words, the conditions that hold after you've invoked the method. And it's just the same as the arrange act assert model. It's just given when then. It's just more readable for more business-oriented people looking at the tests, whereas the arrange act assert is more geared towards kind of like a technical audience, I'd say. So yeah, that's what a good test looks like. That's what a good test method should be composed of. And given that formula, once you get used to it, you can kind of imagine that all tests, if they have to adhere to that formula, so if you need to stick to your test methods being of that format, so having those sections in the test methods themselves, you'd imagine that unit testing could be pretty straightforward. And indeed, in my opinion, for the most part, it is pretty straightforward to write unit tests. However, that said, that presupposes that the code that you're working on, in other words, the production code that you're actually testing, so don't forget we have two different types of code for the two different so-called source code trees. So we have production source code, that's basically the actual product that we've developed, that will be the thing that would be released to production, deployed on a server, packaged up into a distributable, whatever it would be, but the production code itself. And that's different code than the test source code, which resides in the test source tree. The test source code is basically all of the source code for the unit tests and such like. So we have these two very different groups of source code, or packages of source code if you like. And they're normally you'd have in source main Java. So there's a folder called source main Java in, for example, Maven projects. That's where your production source code goes. And then you have another folder, source test Java, and that's where your test source code goes. And also there's not just a separation, by the way, between these actual two different source code trees rooted at source main Java or source test Java. There are also different class paths which go along with those as well. And that's because you want to keep the libraries which your production source code uses separate from the libraries that your test source code uses. For example, it would be wrong if you had a JUnit jar file and a Mockito jar file inside a production WAR file that you were going to deploy to a web server, for example. So having different class paths enables you to effect that different separation and keep them very clearly separate. And all of these things, having good structure to your unit tests, making sure that the production source code and the test source code are separated, making sure that the class paths are completely distinct from one another, those kind of things, they're the hallmarks of good projects. In fact, pretty much they're the base level things that you need to have in a Java project to start to make things workable and to get things into a shape that is organized and manageable. And oftentimes those are the only things that we really kind of think about, kind of like these sort of like surface level things when we're thinking about things like unit testing. And we don't tend to think about things that are a deeper level. So what I'm getting at here, or what I'm starting to drive at, is the fact that even if you have these things in place, where you have best practices around how the actual code is arranged, the structure of the test methods, and the separation between production and test source code, that kind of thing, even if you have those, it's still possible to find yourself in a position where it's difficult to write unit tests. And the reason for this, I've found in my experience, is down to poor design, meaning poor object design, which normally stems from either lack of understanding or appreciation of how to apply object-oriented engineering, or by laziness, which is also possible, or sometimes by some of the constraints which are too advanced to go into here, but like if you're working with legacy code, for example, sometimes it can be difficult to test that code. So what do I mean by bad design? So here's a case where you're going to struggle to write a good unit test. A case where you have a so-called God class. Or probably a better word for it is a kitchen sink class, I think. If you have a class which seems to have every man and his dog wired into it, so if you have a class which has like many other classes wired into it, so if you have a class which depends on many other classes to get its job done, so in other words you have an object at runtime which has many different objects injected into it, or has references to many different objects, and normally when you see these kind of classes you can recognize them because they'll have, say, at least, I guess, 8 different @auto-wired annotations, or at least 8 different fields which have been injected into the class which you're trying to test. And that's always a bad sign, and it's always a bad sign because that one class is actually working directly with 8 different classes underneath it. And if it's having to work with 8 different classes, then clearly it's doing a lot more things than just a single thing that it should really just do and do very well. So we have this notion of like a single responsibility principle in object-oriented design, which goes along with this concept of cohesion. And the idea is basically that an object should really just be programmed to do one thing, and to do one thing very, very well, and to not do many, many, many different things. And when you have an object which has 8, 9, 10 different other objects wired into it, then it doesn't have a clear single responsibility anymore, because typically it's doing many different things because it's interacting with 8 different objects which in turn do different things. Now when you find yourself thinking, I really can't write this unit test, this is like, I'm really struggling to write this unit test, what I've found the majority of the time when I've thought that in the past is because I've been faced with one of these classes, one of these kind of God classes or kitchen sink classes, depending on how you want to term it, and it makes it very difficult because, if we go back to our arrange act assert structure we had before, the arrange section for that would be huge because you're having to now arrange for 8 different objects to basically interact in a way that's sensible for your test. And also the asserts at the end as well. You could spill into those as well. This kind of level of complexity. And you end up maybe trying to do kind of like, dodgy things where you're sort of rationalizing about the class itself, and you're saying, well, look, I've analyzed the code and it seems that, there are 8 dependencies which are being wired in, but only 3 of them, maybe 4 of them, actually, 4 of them, only 4 of them are kind of interacting together. So what I'll do is I'll just set up an arrange section just to set up those 4 objects, and then I should be okay. And you do that, you do an arrange section with just those 4 objects. Maybe you manage to get the test done, you write a few tests, because don't forget, you don't just write one test, you're going to write a suite of tests. So maybe you write like 4, 5, 6 different tests or whatever, arranging those 3 or 4 objects in the way that you see fit for those different tests. You check the code in, test run, everything's good, you move on to your next piece of work. And then at some point, of course, what will happen is somebody will change that class, change the dependencies, or change the way those 3 or 4 different objects interact. And that will then break your test case. And then you'll have to go back and you'll have to understand why it broke your test case. And effectively, what you've done in doing that, you've kind of approached it with the best of intentions, given the time that you had at the time that you had to write the unit test. You've done the best you could do. You had a project manager breathing down your neck to write those unit tests, and you did the best you could. And it was tricky because you had to analyze all the different code paths that, how these 3 or 4 different objects interact. Or actually, not just that. In fact, you basically took the method that you're invoking, the method that's being tested, traced it through under the covers to find out how all the different dependencies which were injected in might interact. You then narrowed it down to 3 or 4 different objects which seemed to interact together. You then had to do this, mental feat of being able to sort of reverse engineer the actual code paths that you wanted those different objects to go down to be able to, write your test. And it becomes very complex very quickly. And what's worse is the fact that once you've done that piece of work, you've effectively built on quicksand because there's nothing concrete about that, because these 3 or 4 different things that you're setting up in your arrange section, they can change. So that's not ideal. And when you have those kind of situations, that's when, at least from my experience, that's when I've found that I'm, quote unquote, struggling to write unit tests. So my point overall, and I appreciate you hanging in there while I got to it, but it's important to dig into detail about it. My point is the fact that you don't actually struggle to write unit tests. Don't think of it like that. Instead of thinking that you struggle to write unit tests, in other words, there's somehow something wrong with you yourself, which is a natural thing for us to think as developers. Don't think of it like that. You're not struggling to write unit tests. It's not a lack of your ability. What's actually happening is you're just being faced with an environment which isn't conducive to writing unit tests. In other words, you're faced with production code that inherently isn't testable given the way it's currently structured. Yeah? So it's not a lack of your skills about how to approach unit testing, this so-called struggling with unit tests. It's not that. More often than not, you're not struggling with your skill set. You're just encountering badly written code which doesn't let you write unit tests in the way that we've spoken about before with this arrange, act, assert, or given, when, then kind of constructs. So the next time you're thinking about, you're struggling with writing unit tests, it probably isn't that. It's probably just that you're looking at code which has been badly written. So of course the next question is, how do you actually fix that? Which again, this would invite a more expansive answer, but how you actually fix it is you need to effectively refactor the code. So there's no two ways about it. If you have a class which relies on 8 other classes, so you've got an object, there are 8 dependencies wired into that object. I say 8, it might be, 9, 10, 6, 5, whatever, however many. You've got basically a lot of different dependencies which are wired into the same object. That class therefore doesn't have a single responsibility. It's got many responsibilities, it's doing many different things. Maybe it's interacting with a messaging service, it's interacting with some kind of warehouse management system, it's interacting with some data store, whatever it might be, doing some validation as well, maybe authorization, whatever it is, it's doing everything. It's almost like the entire application, or at least a large chunk of it, is inside that class. Your option at that stage is basically to refactor the class and to decompose it into different objects. In other words, to evolve it into a proper object-oriented way of doing things, so to evolve it into a proper OO design. And once you've got it to that stage where you've got a decent OO design, where each object adheres to this notion of a single responsibility principle, has a single responsibility, and only has references to 1 or 2 objects to get that responsibility done, where those objects have been sensibly allocated to that object, at that point then, you'll find that those objects can be very easily unit tested using the tools you've already got in your skill set. So the arrange, act, assert, or the given, when, then idea. You can write unit tests and you'll go to sleep at the end of the night as a happy developer. Anyway, that about wraps it up for this episode. If you haven't joined the Facebook group already, please join us. You can ask your questions there. Also, if this conversation kind of went a bit over your head, but you still hung in to the end, I appreciate that. If that's the case, then you might want to check out the JUnit on Mockito course we've got. You can check that out at courses.javaeasily.com, along with all the other Java Easily courses we've got there too, and that should give you a good grounding in these kind of concepts to be able to write unit tests and use mocking frameworks like Mockito, which is how you actually set up these so-called collaborators that you inject into the class under test. Anyway, all that remains to say is thanks for listening. I hope that was helpful. Stay safe and have a great day, and I'll speak next time. We'll see you soon. Bye.